So, good afternoon guys, welcome to NEET World Institute and NEET World YouTube channel. So, in this session as I told we are going to concentrate on this Newton's laws of motion, that is a free body diagram, how to draw the free body diagram, how to take the free body diagram for different cases. Okay, that is the thing we are going to talk in this session, right. So, let us start with the class. Yes. Okay. So, Newton's laws of motion, right. So, as we have talked about the forces, like we have talked about different types of forces also, right. So, what is force? Like either we will say it is a push or pull. This was the basic term we have talked about the forces. Now, the thing which we are going to concentrate on this class is, so normal force, second one is tension, third one is weight, fourth one is friction. Okay, normal force, tension, weight, friction. If anything is we are going to concentrate, I will talk about that one, but yeah, spring force is there, that one we will talk later in the next session. First let us go through these forces, how to draw the free body diagram, everything. Okay. So, how to solve the problem when the problem is given, like the question is given. Okay. So, let us go with the thing. So, what we know, normal is nothing but, like normal force is nothing but I need to draw the diagram with respect to the perpendicular to the surface of the given block or given object, right. So, if I talk, this is my surface and the block is given like this. So, let me consider the block is M. Now, what will be the normal force? Okay. So, this is my normal force, right, exactly perpendicular it will be a normal force. Okay. Now, if I talk about this is my inclined plane, okay, making an angle theta. So, this is my block M. So, how to draw the normal force? It should be perpendicular, right? It should be perpendicular to the surface. Okay, sir. Now, they have given two surfaces. One is block M, the other surface, other block is small m, which is upon the block of capital M. Now, how to draw these kind of like these kind of objects free body diagram? So, what I should do, this capital M having a surface with respect to the ground, but when I talk about the small m, it is having a surface with respect to the capital M block. So, this is my capital M and this is my normal force. First normal force N1. Second one, if I talk about the thing, this is my M and this is my small m. So, the normal force will be looking like this. Now, this is my N2. So, how many normal forces? Two normal forces. I should not say this is my normal. This is totally wrong. This is how we will convert that normals. Okay. So, capital M will be having N1, small m will be having N2. So, if I talk about similarly three objects. So, this one is M1, sir, if they have given. M2 ఇలా ఇచ్చారు, this is my M2. What about M3? This is M3. Sir, looking like a birthday cake. Okay, whatever it is. So, this is my ground level, this is my ground. Okay. Now, I should draw the free body diagram like only for the normal. So, how many normals will this diagram will have? So 1, 2, 3, 3 normals, no? So this M1 will be having N1, this M1. Okay. Next, if I talk about the M2, so this is my M1 and this is my M2. So M2 will be having N2. Similarly, M3 also will be having N3. So 3 normal forces. Okay, sir. This one is fine. What about this kind of surfaces, sir? When a block is given like this M1, the other block is given like this M2. So this is my ground, that is the surface, ground surface. So how to draw this one, sir? What is the first thing? First thing is, how many surfaces did the block or will the block have? How many surface will the block have? How many surface is there for M1? 1, this is my ground surface. One more is there, which is with M2. So can I say this is my M1? So this is my N1. Okay. Similarly, this is my normal, no? This is my normal for M2. So N I will take, N. Okay, sir. When I talk about M2, sir, this is my ground. This is my ground. And one more surface is there with respect to M1. So this is my M2. Normal will be with respect to ground N2, and one more normal. That normal should be equal. Why? Because like both are attached each other, which means the force in between them will be equal. The force in between them will be equal. Got the point? So this is my N. Okay. So this is how we will draw the normal. Got it? Okay. So now we will go for the weight. So this is my M. So what is weight? Weight, it depends upon the gravity, and what gravity, like it always acts towards down, right? That is the thing. Weight is nothing but W is equals to mg. This is my formula for the weight, and it is depends upon the gravity. So I can say that it's always act towards down. So this is my mg. Got it? And now we will club together. The normal force is also there. The normal. Now what is the thing? Since both are in the rest, I mean the object is in rest, okay? Object is in rest. So I can say that N will be equals to mg. The normal force will be equals to weight. Okay. We will talk about the acceleration point once we complete the the diagrammatic point of view. Okay. Okay. Now this one is completed, sir. Now if we talk about what about the inclined or declined surface? Inclined or declined surface. So this is my block M, right? So how the normal force is acting? Normal force is perpendicular to the surface. That doesn't matter how the block is kept, only perpendicular to the surface, normal force. But what about the weight? Weight will be always down, I told, no? That is my mg. Can I say here N is equals to mg? Can I say N is equals to mg in this condition? In this condition? Yes, you can't say N is equals to mg in this condition. It is not possible, right? I'll tell you why. See, sum of force sum of force in the x, only in the x axis will be equals to 0, like only equilibrium condition I am telling, like when they are in the rest, so sum of force in the y direction will be equals to 0, sum of force in the z direction it will be equals to 0. I am talking about only the direction. Since this is one axis and this is separate other axis, I can't say that both are equal. Sir, how to take them in a equilibrium condition, how to consider then sir, how to take or how to write in a mathematical point of view? You told it is not equal, sir, then how? Yes, I will tell you here. So what you should do is draw the axis graphs. So how many parts? 4 parts. Now again divide this one. Again one more part. So how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. Right? Suppose if I take this is my diagram and this is my m, this is my normal force, and what about this one? This is my weight mg. Okay, I will take this as it is. If I keep anywhere, I can place it here, no? So this is my theta, this is my theta. So what you should do is, remember one thing, you have placed theta, like first step is clear, draw the diagram, keep as it is. Now second diagram you should take this one. Okay, second diagram you should take 8 parts, and now whatever the diagram is there, try to adjust in this. So I can adjust here, I can place here, right? Now what you should do is, I have drawn a theta here, give 1, alternatively you should draw theta. Got it? Alternatively I should draw the theta. Now which is the mg? Like mg is towards down, this is my mg. Normal is looking like this is my normal. Now if you see here, this mg, if I want to write here, this is theta. When theta is close to the axis, this one will be mg cos theta, right? When it is away from the axis, this is my mg sin theta. Got it? Now what is the thing I can say? Normal will be equals to mg cos theta. It is not mg. So normal is not equals to mg. Okay, it is not equals to mg. Okay, is equals to mg. I should not write it. So n is equals to mg cos theta. This is my correct answer for the given diagram. So this is how you will draw the diagram when weight and the normal is there. Okay, sometimes you may get this kind of questions, that time you should use this method to get the equations. Okay, this one I should not get, this is totally wrong, this is the correct answer. N is equals to mg cos theta. Okay, got it? Now what about the diagram when they have given in the blocks, like 1 upon 1. So this is my m1, this is my m2. Okay, so m1 if I take one normal force, that is n1 based on the ground, and one mg, that is m1g. Okay, m1g. Okay, fine sir. What about m2 sir? So m2, so one normal force based on the m1, that is n2, and this is one m2g. Got it? Got it? No? Fine. Any doubt over here? So again, if I talk about 3 blocks. So block number 1, block number 2, block number 3. M1, M2, M3 sir. M1, M2, M3 sir. If I talk about this one, M1, this is my normal N1. For m1 there will be a weight, this is my m1g, fine. Similarly m2 also will be having a normal force, and m3 also will be having a normal force as well as the weight. So m2, so this is my n2 and this is my m2g, got it, fine. And what about this one, m3? So normal force will be there n3 and this is m3g, the weight. Now slowly we are building the concept how to club everything, okay. Now if I talk about a block which is adjacent side by side, so this is my block m1, this is my block m2. As we have drawn the normal forces in the previous case, so we will draw the same thing here, the same condition only. This is my m1, a normal force will be there n1 and one more normal due to the m2 block. Similarly, if I draw m2, a normal force based on the m1 block and a normal force based on the ground due to m2, that is n2. Now what is the thing remaining? Weight is remaining. So weight will be m1g, here weight will be m2g, got it. So this was the condition we have drawn in the previous cases with continuation of the part when I talk about a normal force with respect to a weight also. This is the diagram, got it. Done? Okay. So the next thing is tension we'll talk. So tension, like it's always acts away from the body, acts away from the body. Okay, sir. So tension, it's a kind of a normal only, but when we are having a rope in between the blocks, that's it. Okay. So if I talk about pulley is there, so I will take there is a block m1 and one more block is there, this is my m2. I am not talking about which one is having a more mass and which one is having a less mass. I am just talking about the tension, like about the forces, how the like it's acting. Okay, let me take m1 here. So m1, got it. m1 in the sense tension away from the body, this is my body, away, this is my tension T. And one more thing will be there, no, what is that? Can you guess? One more force should be there. What kind of force is that? Can you guess that force? Sorry, yeah, I guess it's clear. Now visible, no, it's visible, fine. So what is that force? Yes, that is a weight. How it will be acting? It will be acting towards down, that is m1g, that's it, no. So I can say that T will be equals to m1g, got it. T will be equals to m1g. What about m2? M2 will be there. What is the first thing I have told in the previous class? Tension. If same rope, same tension. If different rope, different tension. Got it? Same rope, same tension, different rope, different tension. So this is my tension T and this is my M2G. Got it? Ante sir, this is simple as simple. If you understand the concept, it will be easy. Okay, sir, ఇప్పుడు ఇలా చెప్పినారు. Okay, suppose condition ఇలా ఇచ్చారు. ఏం చేద్దాం sir? So this is my M1, this is my M2, this is my M3. ఇలాంటి కండిషన్ ఇచ్చేటప్పుడు మనం ఏం చేయాలి సార్? సార్ ఒక్కటి గుర్తుపెట్టుకోవాలి, దిస్ వన్ ఇస్ అ సేమ్ రోప్ అండ్ దిస్ ఇస్ అనదర్ రోప్, డిఫరెంట్ రోప్, డిఫరెంట్ టెన్షన్. ఓకే, ఐ విల్ టాక్ అబౌట్ ఫస్ట్ M2 or M1 or M3, whatever I want I can take it, like whatever you feel you can take it. Okay, so M2 I am taking, suppose for example M2 I am taking, what are the forces are acting on M2 I should see. So M2 tension will be there because the rope is there, so T I will take away from the body and weight will be there M2G. Okay sir, this is fine. If I talk about M1 sir, what is the things are there, what are the things are there? M1, how many ropes are there? One rope, the other different rope. If I consider this is T, this one is some other variable I need to keep. T1 I can take, no? So this is, yeah, if this is T1, one more is away from the body, one is away like this, one is away like this. So this is T. Is anything is missed out there? Can you check? Is anything is missed out in this? Yes, which one is missed out? In M1 I am talking, which one is missed out? Yes, so which one? Yeah, obviously that is weight will be there, that is M1G. Got it? Now the final one more block is there, that is M3. So M3, it is away from the body, one more down, that is weight. What rope I am using? T1. If this is T, this is T1 I am considering, so I should talk about T1 rope and the weight is M3G. M3G. Okay sir, I will give one more example, you try it, you guys try it. Suppose I have taken like this a pulley, M1, M2, M3 and this is M4. Can you give an answer for this question? Like you can say how many ropes I need to consider, how many tension, different tension I need to consider, that is enough. Then we can proceed with the problem easily. How many ropes, like how many different tensions I need to consider here? How many different tensions? Okay, fine. How many? 3, 4. Okay, so let us see. So for M4 and M1, how many rope it is there? One rope, the connection is 1, so T. T1 let me take, so this also T1 only. M1 and M2, one connection is there, T2. M2 and M3, T3, right? So T1, T2, T3, which is 3 tensions, 3 different tensions. Okay sir, let us draw the diagram now. So my M1, if I take, how many forces are acting if I should see? M1, two tensions away from the body. So one is T2 and one is T1, and what else is remaining? The weight. Weight is, I should always write whether it is contact with the body or not contact with the body, weight will be there. Okay. So weight, it is M1G. Got it? Next M2 I will take. M2. If I talk about M2, sir, how many? 1 and 2. For M2 it is away from the body again. So away from the body in the sense, T2 will be away from the body as well as T3, no? T3 also away from the body. And what about the remaining? M2G will be there. M2G will be there. Next one is M3, sir. How many M3? How many forces? 1, and one more is tension. Sir, one is tension and one more is weight. So tension is acting away from the body, that is T3, and this is M3G. Got it? The next one, final one is M4. So M4, if I consider, this is my, what is the T1, and this is my M4G. That's it. So this is how we will draw the free body diagram for the different blocks for different cases. T1 is a tension and the normal and the weight. Okay, sir. ఇలా ఇచ్చినారు. సపోజ్ ఆబ్జెక్ట్ ఇలా వెళ్తున్నది సార్ ఇన్ ది హారిజాంటల్ సర్ఫేస్లో. ఇది ఒక బ్లాక్ M1 సార్, ఇది ఇంకొక బ్లాక్ M2 సార్. ఇప్పుడు ఇంకొక ఫోర్స్ అప్లై చేసినాం అంటే ఐఎమ్ క్యారింగ్ సంథింగ్ లైక్ దిస్. I'm carrying like this, which means the blocks are going like this. Okay, but I'm not considering the acceleration point of view. I'm saying which side, like what is the things are acting there, I need to consider. That's it, right now. So if I talk about a norm like M1, so M1 if I take, how many forces are acting? Okay, normal force will be there, which is this one, N1 I'll take, and what else? The weight will be there, M1G. Okay, fine. And what else is there? Tension away from the body. So this is my tension. And what about M2? This is my M2. A normal force will be there, N2. And weight will be there, M2G. And yes, the tension will be acting away from the body. And one more force, they have given external force, that is F. So this is how you will draw the free body diagram for this conditions. Got it? Now the final thing is friction. Friction, it's simple, sir. Suppose when friction acts, only when the contact with the surface, right? So if this is my body, if I am going in this direction of force, friction is acting always up in the opposite direction. Always acts in the opposite direction. Got it? Opposite direction. So if I am going like this, if this is a rough surface, so friction will be acting in this direction, no? Right? Okay. If I talk about this condition, a pulley is there. Is there any kind of friction acting here? Any kind of friction acting here? Can anyone say any friction is acting here? No. So when there is a contact, so then I can talk about the friction. When there is no contact, I can't talk about the friction, no? Yes? Okay. So in today's class we have talked about how to draw the free body diagram. Okay, fine. In tomorrow's class, no, we are going to discuss about how to take when the acceleration is applied on the system and how to solve that equations. Okay. So don't miss the next class. So it is very important, and it's very crucial thing. Okay, so until the next class, I'll take a break from you guys. Thank you. Bye bye.